In this video, I want to look at more similarities between trigonometric functions and hyperbolic functions. Let's look first at this. That should have a very familiar feel to it. What would you like that to be? I mean, we know that cos squared x minus sine squared x is cos 2x. It would be very nice if that was cosh 2x. How can we investigate it? Well, we know that cosh x is a half e to the x plus e to the minus x, and sine x is a half e to the x minus e to the minus x. So what I would like you to do now is to pause the video and work that out for yourself and find out whether we do get to cosh 2x or whether we don't. Well, I've written this out for you. Let's have a look and see where it takes us. Here's the expansion of the first bracket, and here's the expansion of the second bracket. We've got a quarter in each. E to the x minus e to the 2x, that's e to the 2x minus e to the 2x, that disappears. 2 minus minus is plus 2, so that's 4. So we get 4 over 4, that's 1. E to the minus 2x, take away e to the minus 2x is 0. So this just gives us 4 over 4, which is 1. Well, that is not necessarily what you were thinking you were going to get. It really raises the question now, what happens if we look at cosh squared x plus sine squared x? Just pause the video and have a go at that one. See what comes out for that. Well, I've done the first couple of lines for you. Let's see where this takes us. We have a quarter, so let's put the quarter outside. Then we have e to the 2x plus e to the 2x, that's 2e to the 2x. Then we have 2 minus 2, so the middle term disappears. And then I'm left with e to the minus 2x plus e to the minus 2x, 2e to the minus 2x. And that gives us a half e to the 2x plus e to the minus 2x, which is, of course, cosh 2x. So these two formulae behave the wrong way. We have cosh squared plus sine squared is cosh 2x, and we had cosh squared minus sine squared was 1. Here's another familiar formula. If this was in trig, this would be sine A cos B plus cos A sine B would be sine of A plus B. Well, we should have learnt, if nothing else, to be suspicious about just transposing trig formulae to hyperbolic ones. So we need to look at this one. This is writing each one in terms of its exponentials. Sine is a half e to the a minus e to the minus a, cosh, cosh, and then sine. And now we just need to work that out. And once again, I've saved you having to watch me write it out term by term. E to the a plus b, e to the a times e to the minus b is e to the minus a minus b, minus e to the minus a, e to the b, and so on. Half times a half in each term comes out to be a quarter. Now we have a quarter outside the bracket, and inside the bracket we've got e to the a plus b plus e to the a plus b, that's 2e to the a plus b, e to the a minus b minus e to the a minus b, that disappears, minus e to the b minus a, plus e to the b minus a, that disappears, minus e to the minus a minus b, minus e to the minus a minus b is minus 2e to the minus a minus b, I can write as minus of a plus b. Now if I cancel the 2, I get a half e to the a plus b minus e to the minus of a plus b, and that is just sine a plus b. It is what we would like it to be. So what pattern have we seen when we're dealing with these? These are the formulae that we've seen so far. Cos squared minus sine squared is 1, and cos squared plus sine squared is 1. Cos squared plus sine squared is cos 2x. Cos squared minus sine squared is cos 2x. And this formula, sine a cos b plus cos a sine b, sine a plus b, worked. Well, it doesn't work, or hasn't with the ones we've got, when we have sine squared. When we have sine squared in the trig formula, we have to have minus sine squared in the hyperbolic formula. This can be shown to be true all the time, and this is known as Osborn's rule. Osborn's rule: if a trig identity involves the product of two signs, change the sign plus minus of that term. So here is the addition formula, no change. Here we have cos 2a, cos squared minus sine squared, cos 2a minus sine squared becomes plus sine squared. Here's one that you might miss. We know that sec squared is 1 plus tan squared. We have to notice that tan squared is sine squared over cos squared. So in this case, you have a hidden product of two signs. So the plus tan squared has to change to minus tan squared.